Good evening. Today we are going to see the most important part in structural analysis, and that we have BMD by superposition and BM net bending moment diagram. So these two are very important if we will talk about structural analysis. Now first try to understand what is BMD on tension side and BMD on compression side. BMD on compression side. So first we will see. So we will consider a beam. And we have on this beam, let us a concentrated load which is 50 kilonewton. Let this is 2 meter, this is 2 meter. So we will have 25 kilonewtons. Reaction centrally placed, so half. Now if you will plot BMD, so now how we will plot it? So we will consider section somewhere here and we will calculate BMD by using this. So now we have letters A, B, C and bending moment at B, we will have 25 into 2 and that will be 50 kilonewton meter. How we will get it as clockwise. Now this is bending moment. So now if I will plot this, so we will have this and then we will plot it. What is bending moment we have? So we will draw clockwise. So like this. So it will take bending moment up and we have habitual with this diagram in mechanics of structure and we will have this as 50 kilonewton meter. So 50 kilonewton meter. Now this BMD, this is on compression side. BMD on. So bending moment diagram which you plot by using moment, that bending moment diagram is known as BMD on compression side. Then which we have our tension side. Now we got this value as 50 kilonewton meter clockwise. Then what will be fixed end moment? So fixed end moment at B should be equal and opposite to the moment at B. Then we will have this will be anti-clockwise. So we will have like this. Value will be same 50 kilonewton meter. Whatever we have shown over here. This is 50 kilonewton meter. So here we have exactly opposite and we have that will be anti-clockwise and it will take beam below and then my bending moment diagram is on tension side. So we will have this BMD on tension side. So this is diagram we have only reversed, values we have same, then polynomial function also we have same, BMD on tension side. So now we have to keep in mind BMD which we are going to plot by using moment, that is BMD on compression side, and which we will plot by fixed end moment, that we are going to say as BMD on tension side. So these two BMDs we have. So that now you have to keep in mind. Suppose we have, so this is compression side, this is tension side. You can take a refill and keep ends in fingers and just apply load from top. Then you will see in that refill we have tension on bottom side and compression on top side, and that we have plotted actually over here. Now if you have UDL and we have in this fashion, and then if you will plot BMD, then we are going to get this BMD. Now you can have, this is on compression side. And if I will plot BMD in this fashion, then we have this BMD on tension side. So simple. So now we will switch over to the problem. We will take 2-3 problems and then you will come to know how we will plot this diagram. Now this is given beam and now we have MAB 86.4 kilonewton meter, and we have this value anti-clockwise. This is value from solved problem. So that we have considered over here. Now if I will draw free body diagram for this, then we will have free body diagram. So in this fashion. So this is simply supported, and we have this value that is equal to 86.4. And then we have this as VA, and then we have this as VB. Then at 2 meter from left, I have this as 90 kilonewton. And then we are going to find out that is BM. We are going to plot BMD. Now you can see this. We are going to plot by 2, that is by superposition and by on tension side. Now for superposition, you have to make separate. So for superposition, I will draw this first. This is fixed end moment diagram. So 86.4. As it is fixed end bending moment diagram, so this diagram we are on tension side always, and we have value 0. So you have always this diagram that is triangle, or we have this diagram as trapezoidal. So we have only two choices. Triangle is actually a special case of trapezoid. So these are only the two forms to plot BMD by fixed end moments. By fixed end moments, or by final moments, we can say. Now I will plot this. So this diagram is always linear line. Now here I have 0, 86.4. So I will plot BMD by superposition. In this first I have plotted due to this. So my orange color diagram. So I have this diagram, and this diagram I am going to get that is due to fixed end moment. Fixed end moments. Now second, I will draw BMD due to load. So we have to make separate. So I will make it separate. So we have this will be beam, and then we have this will be 90 kilonewton. So this we have 2 meters, and this we have 3 meters. Now if you will take a reaction 90 into 2, 180 divided by 5. So we will get it as 36. So we have this value that is 36. Or if we will take on this side, then you have 90 into 3, 270. So we have 54. So we have this as 54 kilonewton. Now if we will draw the bending moment diagram, so now we are going to plot due to bending moment. So 50 into 2, we have that as clockwise, and value this will be 108. If we will take from this side also, 36 into 3, 108. Now this BMD whatever we have plotted, due to this BMD is on tension side. So this BMD we have, which we have plotted by orange color, is on tension side. Now this BMD due to simple support which we are plotting, this BMD we are going to get on compression side, because this we are going to find by moment. And then we are going to get this bending moment diagram. So we have like this value, we will get it as 108. Now due to this, we have bending moment diagram as on compression side. So this is tension side, this is compression side. The portion which is common, that will cancel each other, because one we have plus, another we have minus, and that will be cancelled. So this portion will be cancelled. Then what will be remaining portion? So this portion and this portion we have to plot it. Now when we are going to plot BMD on tension side, this blue we have plotted on compression side. So this portion I have to plot on tension side, because if we will plot this diagram on tension side, how we will get this diagram on tension side? So we will get like this 108. But why we are going to plot on same side? Because we have to cancel the portion which is common to both. And therefore we have plotted it on same side. Now why we are cancelling, that we will see. So now you can see what we will get from this BMD by superposition. So I will plot it. Now we have first portion that is due to orange color, and then due to orange color, now instead of orange I will use this color. So so we have this value as 86.4. Now the point which is common for both have same value and it becomes 0. Now why here we have 86.4? Because due to this diagram is due to simple support, or I can say better, free BMD. This is free BMD. And then at here value of free BMD is 0. Value of fixed end moment is 86.4. So 86.4 minus 0, 86.4. Now this point where we have same values from both will cancel each other, and my value at this point on tension side becomes 0. So we have this triangle portion. So this triangle we have plotted over here. Now we have to plot this triangle. Now if you will calculate value at under the concentrated load for free BMD, then we have this value that is equal to 51.94. So we have this value that is 51.84. And now from this we can find the net value under the load. Now net value under the load we will have now 108 minus 51.84, and from this we will get it as 16, then 26164. So 46.14 and will be under this point. So we will have under this point 46.14. So we will have this as, so sorry, 84.1 and then 7, then no we have any value, so we will get it as 56. So this is 56.16. So we will have 56.16, and this is BMD on tension side. BMD on tension side. Now if you have to plot this diagram directly, then how you will go for this direct? Then we will have this. Then this we have 86.4. We will have this value which is 90 kilonewton. And then 2 meters. And then we have 3 meters. And then you have first 86.4. So we will take it as 86.4. Now again, if I will take this 86.4 as it is, then this BMD will be on compression side. Means if I will plot this in this fashion, somewhere here under the load we have 56.16. So this BMD, so this is BMD on compression side. Because this we have plotted due to moment, and therefore we have to keep in mind, so that you can see this. I will take this as 86.4 and it will take below. And if I will calculate at this point, then due to reaction, due to 86.4, it will take up. And then we are going to get this value that is 56.16. And then we will have same diagram, only we have opposite. So this is on compression side. This diagram is on tension side. Then one we will see, and so we have this as, so these diagrams we have to plot actually. So we will go next part in next video. So we will stop here only. So thank you.